Greetings everyone, and welcome to our first demonstration video. In this video, we're going to be showing you how to use one of the tools we talked about in Module 1. This tool is called the Impact Chain Analysis tool. This video is meant to be used after you've completed the self-guided presentation for Module 1. And also after you've reviewed the guide for the Impact Chain Analysis tool. So we're going to assume that you have a little bit of background knowledge already and that you know what the tool is for and why we've created it. So as you watch this video, it may help you to have the guide for the Impact Chain Analysis tool handy. So let's go ahead and get started here. Now first we'll have a quick recap to make sure that we understand what this is all about. So the climate change impact analysis tool is really to help us develop our climate change evidence base. And the climate change evidence base is one of the most critical parts of the concept note that you're developing. The climate change evidence base allows us to draw a very clear line between the physical processes of climate change and what your project is going to do. So it shows to GCF that everything in your project can be linked back to climate change. And the reason that you're doing your project is because of the impacts of climate change. Now this is really important because the Green Climate Fund and other financiers have been designed specifically to address problems that are caused by climate change rather than those that are driven by human factors such as mismanagement of resources or poor governance or economic crises or other basic economic and social development issues. Now it's not that these things are not important to the Green Climate Fund, but in its establishment it was set up to focus specifically on climate change issues, and that's part of the fundamental agreement behind the Green Climate Fund. So now we talk about development projects versus climate change projects. And so what's the difference here? Well, simply put, climate change projects address problems that are being driven primarily by the physical processes of climate change. So this is the increasing temperatures and changing patterns of rainfall or precipitation, sea level rise or changes in climate and meteorological conditions and extremes. Development projects, on the other hand, seek to address fundamental socioeconomic, governance, natural resource management, and conservation issues. So the key difference here is the causality. A climate change problem for a climate change project is caused by climate change, whereas a development project addresses a problem that comes from development issues. So, like I said, the Green Climate Fund will not fund development projects. They only fund climate change projects. Now, certainly when you develop your climate change project, there will be development co-benefits. And that's actually one of the investment criteria for the Green Climate Fund, that projects have sustainable development potential, that they align with, that they provide environmental or social or economic co-benefits. But we always have to make sure that our project is rooted in climate change and not development issues. So the evidence base helps us to do that. So let's look at a GCF definition of the climate change evidence base. And what we see here, the climate change evidence base provides the scientific underpinning for climate action and climate action decision making, and the theory of change for all kinds of activities funded by the GCF. It demonstrates the connection between the physical processes of climate change, their impact on society, and the benefits that the proposed project will deliver. The evidence base is grounded in the best available data and science concerning the most relevant climate factors. Right, so we've already covered this in the module. But let me emphasize here a couple of points about this definition. And number one, I think you can see my pointer here, is the evidence base provides a scientific underpinning for climate action. The scientific underpinning, and then down here, the evidence base is grounded in the best available data and science. So that means that it's grounded. That means that it's based on. It's based on the best available data and science concerning the most relevant climate factors. Right? It references the best available data and science, and that's the scientific underpinning. So everything that we talk about here is based on observations of what has taken place in the past and what's currently taking place, or good projections of what will take place in the future. So we don't just make up the evidence base. It has to be based on reliable sources, data and information. So the key point of the evidence base and the impact chain analysis tool is to demonstrate that your project is a climate change project and not a development project. So as you work with the GCF in developing your concept note, it's very likely and inevitable that you will go through several rounds of revision with your concept note with GCF. So when you submit your concept note to GCF, that's never the end of it. It's never approved on the first iteration. Even with the largest and the most proficient and most experienced organizations, they have to go through several rounds of revision with the GCF. And so you will too. So you can think about developing your concept note almost as a partnership or a process of co-development in which the GCF is providing input through their comments to guide the development of your concept note. So when they send back comments, when they provide comments on your drafts, one of the things that they most commonly ask about is for more information on your evidence base. They want further clarification that the activities associated with your project, that the things that your project is doing are addressing a climate change problem. And so the impact chain analysis tool and the evidence base that we're developing should help you move in that direction and get the information that you need to clearly lay this out. So here, the evidence base, what does it do? It helps to ensure that the problem being addressed by your project is a climate change problem and not a development problem. That's what this is all about, and that's what this tool is all about. So you can think of the evidence base as a story. That's what I like to do when I'm developing projects. I think about various elements of the project as a story. And so your evidence base, your climate change evidence base, it's a story in and of itself. It describes how climate change is unfolding in your country, the manifestations of climate change, what climate change looks like in your country, what's happening. And also another part of that story is the impacts that it's having on human systems. How is it harming people, places, and things? And that really tells you the relevance of climate change. So the climate change analysis, it's a tool that will help you formulate a plot, a logical plot to this story, and a plot that is backed up by data and information that's grounded in science, like we saw on the last slide. So now there's 4 elements of the impact chain analysis, and we'll step through these one by one. This is our terminology. These are our terms, our lingo, our nomenclature, if you will. So the first is a climate change driver. That's the first thing that we're looking for, the climate change driver. And this is quite simple. These are the physical processes of climate change, the things that you can directly link to climate change. They're big picture physical processes of climate change that the country is experiencing or will experience in the future. And remember, these must be linked directly to climate change. So this includes things such as increased temperatures or sea level rise or more intense storms, changing patterns of precipitation. You can think about them as changes in environmental conditions, changes in environmental conditions. That's what they are. They're changes in temperature and precipitation, more frequent cyclones or typhoons, or more intense cyclones and typhoons, those sort of things. Now our next step is to look at the hazards. And this is how a physical process is experienced locally. So a definition that the IPCC, the Intergovernmental Panel on Climate Change, uses sometimes is this. It's a natural or human-caused physical event or trend that can lead to harm or damage to people, places, or things. So this includes things like flooding, drought, coral bleaching, landslides, or coastal erosion. I tend to think of hazards as the environmental changes plus the local geography. So again, these are linked to climate change, but they're not directly caused by climate change. They're not directly caused by global warming. You need a combination of some local geography and the climate change driver, the physical process, in order to have a hazard. And when we're working on a concept note, one thing to bear in mind is that we should focus on the sector that our project is going to address. So for example, if you're focusing on the agriculture sector, then you will look at analyses and information on how physical processes like increasing temperature or storm surge may affect crop growth. That's what we're looking for here. So those are the hazards. Next, after the hazards, we have our exposure pathways. And the exposure pathway is that's how the hazard can hurt people, places, and things. So you think about a flood, for example. There are many different ways that a flood can cause damage. It can cause harm to people. Flooding can cause damage to structures. It can cause damage to roads. It can cause crop inundation. It can lead to pest outbreaks and things like that. So those are our exposure pathways. Now these are slightly different from hazards. And the point here is not to confuse you, but what we're trying to do is very clearly lay out the steps from the climate change driver to the impact. So we have our climate change driver, our hazard, and our exposure pathway. The exposure pathway is how have the enhanced hazards affected, or how will they affect human systems in the future? So as you can see my examples here, reduced crop yields and contaminated drinking water. And again, we'll look at some examples in a moment. Now then we've got our impact. The impact is a harm and damage that results from an exposure pathway. So this describes how people are harmed after being exposed to the hazard. And it may include things like reduced food security, loss of income, or malnutrition, reduced availability of drinking water. But what I'd like to call your attention to here is each of these example impacts. Reduced food security. Now, reduced food security doesn't necessarily have to be caused by climate change, right? It can be caused by a number of different factors. It can be caused by soil depletion. It can be caused by market issues, by economic issues. It can be caused by all sorts of things that are not related to climate change. The same thing with loss of income. Loss of income could be driven by many, many non-climate factors, as can malnutrition or reduced availability of drinking water. If we poorly manage our drinking water supplies, if we allow a lot of pollution in our rivers and lakes, or if we allow for our aquifers, our groundwater, the water that is beneath the ground, to be taken out too rapidly and unsustainably, well, that can lead to a reduction in availability of drinking water. So each one of these impacts could be driven by something other than climate change. So the point of the impact chain analysis, the key thing, the advantage of it, why we use it, is because it helps us to draw the line between the climate change driver up here and the impact down here, right? So stepping through these pieces is very important because we can back up each of these things with data and information to demonstrate, to prove to the GCF that this impact is actually ultimately rooted in the climate change driver, right? So now let's look at an example. This is from a workshop that we did a number of years ago. And this is looking at impacts for the agriculture sector. And as you can see, we did this on paper strips so that they can be moved around, that they can be changed. In the era of COVID, I've been doing this on my computer using PowerPoint boxes and moving those around. But we'll start off with our climate change driver, and these are things that are linked directly to climate change. And we've got unpredictable weather patterns, so changing seasons, the dry season getting longer and the wet season getting shorter, and the wet season starting at irregular times, all of those things we see in many places around the world. And then we've got increased precipitation. Now that may be happening in your country or in your region. In other regions we may have decreased precipitation. Or we may have extreme weather events, like more rainfall falling over a shorter period of time, that sort of thing. More thunderstorms, more hail, more flash flood, more extreme rainfall events. More extreme high temperature days, and fewer cool nights, right? And then we've got increased temperatures overall. This is a gradual long-term increase in temperature. So all of these are changes in environmental conditions, as I mentioned earlier. And what do they lead to? They lead to a number of hazards. And like we said, these hazards are processes that can hurt people, places, and things. We've got drought, erosion, and landslides. We've got extended flooding, frost. Frost is probably not as common in tropical parts of the world, but there may be some places, especially higher places, that are experiencing more frost. We've got strong winds, fires, and this is a strange one down here. Remember, this is from a group. Big raindrops. And there's an explanation behind that. There's a story behind that. And if you ever meet me in person, I'll explain big raindrops to you. But let's just move on. So the hazards, right, are droughts and so forth. And then over here we have our exposure pathway, and I changed the title of this because we had a different title of it, but it's still exposure pathways. So if we have increased temperatures, that may lead us to some droughts. Yeah, and if we have droughts, how can that hurt you? How can that hurt you? Well, it can hurt you through failed crops and reduced yields. Yeah. We've got physical and economic displacement. I actually would probably move this to impacts. Yeah. We've got destruction of agriculture infrastructure. That definitely is an exposure pathway. Destruction of agricultural infrastructure, that may come from extreme weather events, right? From extended flooding or from landslides. We can definitely see how a landslide or extended flooding could damage some irrigation channels or some other farming infrastructure, some agriculture infrastructure. We've got pest and diseases as an exposure pathway, increase in waterborne diseases and vector-borne diseases, siltation of streams, interruption of supply chains, and all of these things. These are exposure pathways that are caused by the hazards. And then lastly over here we have our impacts. And these are the big picture things, that how people, places, and things are harmed. Now it may take you a little bit of practice to get this down. And if you're confusing the hazards and the exposure pathways, or the exposure pathways and the impacts, that's really okay. The key thing that we want to do here is be able to draw a very clear line between, what's happening in the environment, what's happening with climate change, and is it making these hazards more likely to happen? Or is it introducing new hazards? And if it is, how are those hazards harming people, right? What's the process by which a hazard can harm people? And then lastly, what's the impact of that harm, right? And so for each of these things, unpredictable weather patterns, we would want to provide some information, some data and information. And we can probably find that in our NAP, our National Adaptation Plan, or our NAPA, National Adaptation Program of Action, or some of those documents, some vulnerability assessments and so forth. Those are good sources. You don't have to do the research, the original research yourself. There's usually a source from the government that we can find. Same thing with the hazards, right? If we say that increased temperature in our country is leading to more drought, we should be able to show a record of drought over the past 30 years or over the past 50 years, so that we can point to that and say, yes, indeed, droughts are becoming more frequent, and this is how we can prove it. And then the same thing with these things. If we've got failed crops and reduced yields, we would want to tie those things with records from the Department of Agriculture or the Ministry of Agriculture or wherever those records may be. We would tie those records to the occurrence of drought. So what we're showing here is we're telling a story, but with very good sources, with evidence that, well, yes, we indeed are experiencing more temperatures. We can show that with the numbers that we have, with the temperature data that we have. And this is causing more drought, and we can show this as well. And in fact, when we look at the economic damage and we look at the yield numbers, the statistics that come from our Ministry of Agriculture, indeed, when we have a drought, we have more failed crops and reduced yields, and it's becoming an increasing problem. And that is impacting people. It's creating food security. It's causing farmers to default on their loans because they have low yields and they cannot pay back the loan. It's affecting our livelihoods and so forth. So I think you can get the idea here is that what we're trying to do, we're drawing a very clear line here. We're telling a story. Yeah. So let's move on. So let's look at another example, and we'll talk through this one. This is a made-up example. So we're going to be using a country, a hypothetical, a fictional country that we made up for the purposes of this course. And we'll follow this country through all of the modules in the workshop. And so we're going to revisit this story. But our example here is an island nation. It's called Ketopia. So Ketopia, and yes, I named Ketopia after myself. It's in fact a beautiful country. It's my favorite place to visit. Excellent cuisine and wonderful hospitality and a great culture. The island nation of Ketopia, it's a least developed country and a small island developing state. And it's highly vulnerable to changes in climate, such as increased temperature and sea level rise and extreme weather events that result in high winds, flooding, and storm surge. So see here, we've already got two elements of our impact chain analysis. We have our physical processes of climate change. These are the changes in environmental conditions driven by global warming, and that includes increasing temperature as directly related to global warming. Sea level rise, again, directly related to global warming, and then extreme weather events. And then we have our hazards here, the high winds and flooding and storm surge. So we have our physical processes, but we also have the hazards, which are the processes that can hurt people, places, and things. So another hazard that's been observed is a significant increase in drought occurrence. So we have more and more drought here in Ketopia, and that's coming from climate change. We've observed this over time, over the years. Since 1950, we have recorded a real increase in droughts, especially in the past 20 years. Now, these observed changes to the climate are having very negative effects on our agriculture sector. And as a least developed country, as a small island developing state, our agriculture sector is very important to us. We have a lot of subsistence farmers, and so they're very vulnerable to the negative impacts of climate change. And so we're worried about these impacts on agriculture, and we know that they're going to get worse in the future if we don't do anything about it. So the rise in temperatures is increasing water demand also. So we have more evapotranspiration because the temperature is higher, and that's damaging our crops. But we also have an increase in pests too, bugs, crop pests that are damaging our crops. So we're being hit on multiple fronts here because of these changing environmental conditions. So then in 2018, a tropical cyclone came through. It's Tropical Cyclone Karen. And Karen came through and produced heavy rains that resulted in highland flooding up in the mountains but also a storm surge would cause coastal flooding and damage to crops, and saltwater inundation of some of our coastal soil. And this was a big deal because it was this event was out of the ordinary. We were not used to having so many tropical cyclones or so intense, but they seem to be happening more frequently and more intensely in the past 20 to 30 years. So future projections, these are the projections for the future climate conditions that may happen. These are suggesting that temperatures will continue to rise. And we're fairly certain about that. We're very certain that temperatures are going to continue to rise. And that storms, when they do happen, they're going to become more intense. And part of this is because the seawater is warmer, and that fuels more intense tropical cyclones. So the government of Ketopia, well, we're really concerned about the threats to agricultural productivity and food security. Right now, 60% of our population is engaged in subsistence agriculture. So we're highly dependent on subsistence agriculture. And we're worried about what climate change will do to that sector, but also to the people. So we'll move on and think about how we can put together an impact chain for this. And again, you can see we've got our climate change driver, we've got our hazards, we've got our exposure pathways, and then we've got our impacts. So let's make sure that before we think about even doing a project, we want to make sure that we have our climate rationale laid out, because this is one of the most important pillars of an adaptation concept note, of a project concept note. So the climate change drivers, as we said, these are going to be things like increasing temperatures. And we can document this. We have data and information. We have a historical record of increasing temperatures. We've got measurements at our airport. And then there's another hydrometeorological station on the other side of our island. So we have a record over the past 50 years of increasing temperatures. We also have the global record of increasing temperatures as well. And then what's our hazard is a change in seasons, plant and animal heat stress. These things are happening because of increasing temperatures and increased pests. So when the temperature goes up, it's more welcoming to certain pests that affect our important agricultural products. And so then what happens? We look at our exposure pathway. How do those hazards, how do they affect people? How can they harm people, places, and things? Well, they can lead to lower crop yields. Right, lower crop yields comes from increased pests and plants and animal and heat stress, and damage to crops, damage to livestock, and as you can see, all of these things. So we're telling a story here, and remember, we have to be able to back all of these things up. So we have data and information, we have reports and analyses that indicate that all of these things are true. And then our next step, or our next climate change driver, is increasing storm intensity. Our cyclones, the tropical cyclones, are getting stronger. So that leads to increased flooding. That's a hazard. And also increased storm surge, like higher storm surge. And storm surge is the big waves that come out in front of a tropical cyclone. And they're very damaging. They're one of the most damaging parts of tropical cyclones. And then we also have increased winds that are coming. So all of these things are hazards associated with increasing cyclone intensity here. Yeah. So what happens? This can lead to damage to infrastructure and contaminated water. And all of these things together, the impact, the bigger picture way that this affects our community is through a loss of food security and loss of income for farmers. See, this tells us that these problems are really bad. This is why we're worried about this. Health impacts, disruptions to the community, and so forth. Now, these are the things over here that we need to really adapt to. We want to make sure that we don't have a loss of food security. We don't have a loss of income from climate change. These are the things that we're worried about right here, right? We can't control the increasing temperatures, and we cannot control the increasing storm intensity. But what we control maybe with a project is these impacts over here. So this is what your project is going to focus on. And the whole point of this tool is to make sure that we can draw a logical and evidence-based link from these impacts all the way back to these climate change drivers. Let's see if we've got some more here. So the project is ultimately going to be derived from this part of your impact chain analysis. That's what your project is going to address, probably. Lower crop yields and loss of food security, damage to crops, damage to livestock. These are the things that we're going to adapt to, right? And so we need to make sure, like I said, that these things are linked to climate change. So the project designed to specifically alter the exposure pathway reduces the impacts felt on society, right? So we can change this in some cases, not all cases, but in some cases we can change this, or we can change this. We just have to decide which one. So the key point, like I said, of the exercise is that all of the items listed have a clear connection to climate change. And if you have a good impact chain analysis, where all of the parts of the impact chain analysis are backed up by data and information, then you will have a good evidence base, so the basis for a good evidence base. So before we end, I'd like to show you one more example. And this is an example from an actual project, concept note for a GCF project that I've worked on. So this is one that I developed myself for a project. What we see here is this is in a small island developing state. And what we see here is that we've got our physical processes over here, our hazards, exposure pathways, and our impact, just like the methodology that I've shown you. So this is what I do when I'm developing projects. Other project developers may do things differently or use a different tool, but I've found that this technique is very, very useful for ensuring that I have a good climate linkages and a good evidence base. And as you can see, I just simply made this on PowerPoint, right? Because this is a COVID era impact chain analysis. So you can see we've got higher temperatures and increasing rainfall, decreasing rainfall in some seasons, and more powerful cyclones. So all of these things are affecting this particular country. Now, and we can also document these, right? We have a national adaptation plan that actually has the numbers, it has the records that we can refer to. So we don't have to go out and collect this data ourselves. It usually exists someplace. It's just referencing the correct information and the correct data. So we can trace this because we've got arrows, right? So we've got high temperatures, and then we've got hazards, which have also been observed. We've got records on these, and that's why these are in the impact chain analysis, because I can demonstrate with data and information that all of these things are indeed occurring. But what does higher temperatures lead to? It leads to increased evapotranspiration and more heat stress for plants and waterlogging not higher temperatures there, but higher temperatures can lead to decreased soil bulk density because the water is being dried out of the soil. It can lead to what? It can lead to drought, and then increasing rainfall leads to waterlogging of the soil. It also leads to more overland flow and runoff. Decreasing rainfall contributes to drought and decreased soil bulk density. And then we've got more powerful cyclones, which leads to flooding, powerful winds, and more overland flow. And we can follow these things on to increase evapotranspiration. Well, how does that hurt people? Well, according to our vulnerability assessments, our village work that we did in this particular country, it leads to early maturity of some species, but also wilting. That means that the leaves die, right? Heat stress also can contribute to wilting. The decreased bulk density leads to decreased tuber size. So in the sweet potatoes that people grow for subsistence, they're smaller. And also rotting roots, We've got drought that is leading to declining yields. And all of these things here, they're contributing to the broader problem of decreasing food security. And that's an impact there. And what does that lead to? Well, we're spending more money on imported food. And in this particular place, it's quite poor. It's the rural incomes are not very high. And so the more money that people have to spend on imported food, the less they can spend on other things like school fees or things like that. Decreasing food security also leads to an increase in non-communicable diseases, right? Things like diabetes and heart disease and so forth, especially if they're not eating, if the people are not eating as healthfully, or if they're not eating things that they're used to eating, as they're eating a lot of cheaper junk food. Villages are in a constant state of recovery, and then declining incomes from agricultural produce. And all of these things lead to decreased adaptive capacity, right? So ideally, our project will probably focus on some of these things here, right? That those are the impacts that we want to address. And we may work on these exposure pathways too, because we want to decrease exposure. And by doing that, we should decrease the impacts here. But all of those are things that we'll talk about in future modules, and we've got other tools that are going to take us the rest of the way. What the impact chain analysis has done for us is made sure that the impacts that we're looking at, the issues that we're looking at, are actually rooted in climate change. And that's a really good place to start your project development process. So that's it for our impact chain analysis demonstration. Try it yourself. Use the guide, and come back and watch the video again if you need to. And again, it takes some practice to do impact chain analysis, but it's really not as hard as it looks. The key thing is to make sure that you've got data and information to back up everything that you put in the impact chain analysis. Have a great day, and we'll see you in the next module.